Right, within this lesson, year seven, you need to show you're working out where possible. You also need to complete all the tasks that are set out within this lesson. You're going to be comparing fractions, and you're also going to be converting fractions into decimals. On slide 6, you will see that I've created a video on how you can use the bus-stop method to convert fractions into decimals. And I'm hoping that makes sense to you, because you will need to acquire that skill in order to convert the fractions into decimals. But before we get there, my intentions are to go through one example on how we compare fractions first. If you can start off by completing a starter where I need you to complete your 2 times tables and your 3 times tables and your 4 times tables all the way to your 10 times tables, please. Please write them out in full and then put the answer. Thank you very much. Now you can only ever compare fractions if the denominator, which is the bottom number of the fraction, is the same. So if we look at these three fractions that we have here, 2 over 5, 1 over 4, and 3 over 8, the first question I want you to ask yourself is, what is the lowest common multiple in the denominators 5, 4, and 8? And all that question is saying, what is the lowest number that appears in all of these times tables? Now, if you did the starter, you would see that you've got your 5s, 4s, and 8s, and you'd see that the lowest number that appears in all of those times tables is 40. So effectively, all of our denominators for our fractions are going to change into 40. So if we start off with 2 over 5, that can only change into 40 if we multiply 5 by 8. So we must also multiply the top, the numerator, by 8. 2 times 8 is 16, hence why it changes to 16 over 40. Same thing with 1 over 4. 4 can only change to 40 by doing 4 times 10. So you need to do 1 times 10, which gives us 10 over 40. And the last one, 8, can only turn into 40 by doing times by 5. So 3 times 5, which is 15 over 40. From here, because our denominators are the same, our bottom numbers are the same, we can now order these fractions just by looking at the number that has the highest and the number that has the smallest number. So if we look at those numbers, 1 out of 4 should go first because 10 out of 40 is the smallest. Next, you should have 15 out of 40, which is 3 over 8. And then the last one will be 2 over 5. And your fractions are now ordered in terms of how big they are. When you move on to the next slide, you will see a range of tasks. I want you to all start from green, then you can decide whether you want to move on to yellow or red. If you want to do all 3 tasks, that is fine by me, but we are all to start from green so that we can embed the idea of making sure that our denominators have the use of our lowest common multiples. Now suppose I wanted to change 1 over 2, the fraction 1 over 2 into, pardon me, into a decimal. All I'm going to do is 1 divided by 2, and if you didn't know, the little fraction line actually means division. It actually means divide. So 1 over 2 just means 1 divided by 2. And if we use the bus stop method, you'll see that 1 divided by 2 is 0.5. Alright. Now I'm not going to explain how on this slide, because in the next slide you will see a video of me talking you through numerous examples where I use this bus stop method to divide our fractions and to turn them into decimals. Alright, so I'm going to go through 4 examples very quickly. And then, yeah, that will hopefully explain how you convert fractions into decimals. So the first thing, well, all I'm going to go through is the bus stop method on how we divide. So I'll just start off by going through the first one, which is 1 divided by 2. So if I was converting 1 over 2 into a decimal, well, we're going to do 1 divided by 2. And we're going to use the bus stop method. So 2 goes there, 1 goes there. And you start off by asking yourself, well, how many 2's go into 1? 0. And because nothing goes into 1, you need to add a 0 here. When you add this 0, you need to make sure you put a decimal point here. And the only reason we put that decimal point there is because of this 0 that we put here. But now we look at this as the number 10. We don't ask ourselves, well, how many 2's go into 10? But that is just 0.5. So when you convert 1 over 2 into a decimal, you should end up with 0.5. If we go back to our next example, which is 1 over 4, we're going to have a go at 1 over 4. So that is 1 divided by 4. 4 goes here, 1 goes here. How many 4's go into 1? 0. Nothing goes into 1, we need to add the 0 onto it. There's no other numbers next to it. By putting the 0 here, you need to put a decimal point there. How many 4's go into 10? Well, 2. Remainder 2. How many 4's go into 2? None, so we need to add the 0. Now what you don't have to do is add another decimal point because that would mathematically make sense, but you just add your 0 here and you look at it as 20. How many 4's go into 20? 5. So when we convert 1 over 4 into a decimal, we end up with 0.25. If we look at our next example, we've got 1 over 3. And we're going to change that into a decimal. Right. So this is effectively 1 divided by 3, which we write as 3 here and 1 here. How many 3's go into 1? 0. Add the 0 here. You must put decimal point because we've added that 0. How many 3's go into 10? 3. Remainder 1. How many 3's go into 1? 0. 3. Remainder 1. How many 3's go into 1? 0. How many 3's go into 10? 3. And this pattern is just going to continue. And what we actually call this kind of decimal is a recurring decimal. So if you see that the pattern is going to continue, you just put 0.3 and then put a little star on top of it, which tells us it's a recurring decimal. It never ends. That pattern will continue going. Right? We'll not end up with a final answer. It will be 0.33333 for forever. Our last and final example that I want to go through is 1 over 8, and I'm going to show you how 1 over 8 gets to 1.25. So if I stop sharing it. So we've got 1 over 8. 8 goes here, 1 goes here. Well, how many 8's go into 1? 0. You need to pop a 0 here to make it big enough for 8 to go into 10. By putting the 0 here, you must put a decimal point there. How many 8's go into 10? 1. Remainder 2. 8 doesn't go into 2, so you pop a 0 here. How many 8's go into 20? 2. Remainder 4. How many 8's go into 4? None. You add the 0 here. But how many 8's go into 40? 5, which is how that turns into 0.125. Please make sure that you use the bus stop method as explained in the previous slide. You've got 3 or 4 examples that you can refer to from that video. Should you still need further assistance please pop me an email. And the idea is that hopefully during this week's drop-in session, I'll be able to address the issues that you may have encountered whilst trying to convert fractions into decimals using the bus stop method. Once you have finished the task 3 questions, please move on to slide 8, where there is an extension task for you to complete. Once you have completed all the tasks set out, please make sure that you have completed and shown all of your working out for all the tasks that you've completed within this lesson, please. I want you to assess your performance and tell me whether you're happy with your understanding of ordering fractions and converting fractions into decimals. I want you to tell me what you have struggled with and what you have found straightforward. I don't want you to write down 2 things you think you've picked up from today's lesson. And then you may have a go at the problem below. It says, what have all of these got in common? My advice to you is that you try to convert these into decimals, and that should answer your question. You'll be able to tell me what they have in common. Once you've done all of that, please make sure you put your name on your work, my name on your work, and please make sure that you've emailed your work to me, to my email, which is also in the lesson description on Satchel 1. And if you can, please upload your work onto Satchel 1 directly. Thank you very much. Take care.